So another title that has been on this before, or at least a similar talk, included something called Hoppy. Who knows what Hoppy is? Daniel knows what Hoppy is. He should, but that doesn't count. Hoppy, we'll talk about Hoppy. Hoppy is something that's short for hypermedia authentication API. That's the API-driven part in here. Who knows what passkeys are? A few more. WebAuthn? Related to passkeys. Okay, so those are the things we're going to talk about. Hypermedia authentication API is much easier to say Hoppy. Is something that we developed to kind of be able to move away from the browser when doing authentication, OAuth and OpenID connect flows on mobile devices, predominantly mobile devices. It doesn't have to be a mobile device, but that's where it makes most sense. Because if you think of a web application, you're already in the browser, so doing a server-side rendered authentication, it's just in there, right? It doesn't really change that much. There are other benefits too, obviously, but it makes most sense on mobile, which is also what I'm gonna demo, if it works. A huge part of the drivers here is this part, for sure. Seamless login and authentication, and making it sort of seamless in a mobile device. I don't know how many have seen, like when you authenticate on a mobile application, that you kind of get sort of a pop-up on top of the app, right? Which is it's called the web view, or it is the browser context. That's because OAuth flows needs to run there traditionally. So you get that pop-up and then you log in and then you kind of get switched back, and it's not really that slick. The other part that the app developers that are developing that app probably don't like is the fact that authentication is it's server-side render. They control the UX of the application itself, but then they lose complete control over how that authentication screen works or looks, because it's in the hands of whoever sort of owns the authorization server that renders this authentication. So UX control and sort of reducing the friction involved in the login process of that application. And then you get into that controlling branding of login views. It's like all of a sudden the app developers, if you can run this authentication natively within the mobile application itself, they can control exactly what it looks like, right? And so that's some of the drivers for this. So Hoppy handles authentication without a browser. You can use, and I point this out, that you can use any authentication mechanism, because at least Curity supports somewhere, I don't know, 35, 40, what do you think, Daniel? 40-ish authentication mechanisms, and you can basically run all of them. So we're not bound to like, this is the only authentication we can run. We can run essentially anything there. Authentication workflow is a point to say that we at Curity at least have something that we call authentication actions. They are small little snippets that can execute after an authenticator has executed, or you've successfully authenticated. We can do a bunch of stuff after that. It could be things like contextually trigger a multi-factor authentication depending on your username or your email or whatever it might have been. We can check if you're logging in from a new country and therefore do something different and whatnot. So there's small little snippets that can execute post authentication, and they can also run in this context of the hypermedia API. Localization and branding, we kind of discussed. We have full control over how we render the UI, because Hoppy is essentially just returning JSON information, and then it's up to the app developer to like, how do I actually render this authentication? And then last but not least, we can keep using our traditional standard OAuth clients. It's the same client essentially that we use for any other app. I mean, I would practically segregate them, but there's no difference in the configuration for it and how they behave. if we look at it from a diagram perspective, this is a traditional OAuth flow where you have the mobile app. It kind of moves into the browser context that executes, in this case, a code flow. And the user authentication happens in the browser to server in the front channel. And eventually a token is issued. But if you run a Hoppy flow, it simplifies the diagram, but that's not necessarily the point. But we expose a different API on the authorization server, and we run the user authentication natively directly from the mobile application itself without invoking a browser. So all of that is the first part of the title, right? Ditch the browser. So Hoppy solves the need for the browser context on a mobile device. The next part of running this passwordless to make it really, really seamless on a mobile application, we can do passwordless authentication in any number of ways, but a really popular one and a really secure one and phishing resistant option is WebAuthn. I'm actually going to use Passkeys in my demo, but Passkeys are built on top of WebAuthn, so I thought it would be kind of a good deal to explain a little bit about WebAuthn. It is an API that solves registration and authentication for user authentication. You can do it in a bunch of different ways. A very common way of WebAuthn is to leverage like a hardware token. I have one here in my laptop, but you can't see it. It's a YubiKey. So in that part, there's a process of registration and registering my YubiKey with whatever service that I'm using. Could be my bank, for example. And when that's done, you can run the process of authentication. So without going into the nitty-gritty details of all of it, it's using a key pair for each service that you use, that you register with. So if someone would sort of breach Bank of America, if that's my bank, to get hold of this information, they can't reuse it with another service because it's a unique key pair with each service that you use it with. Does that make sense? So we kind of move away from this big problem that I use the same password everywhere, and if it gets stolen from someplace, the attacker can use my password everywhere, right? That doesn't work, and it doesn't happen with WebAuthn. So it removes the need to securely stored passwords because there's no password to store anywhere. That's sort of obvious when it's passwordless authentication, right? It solves that problem with same password everywhere. You can leverage this together with additional factors. You can kind of chain authentication, right? You could do WebAuthn as your one factor, but you can also add on something else. You can do Duo in conjunction with this, or like an email authentication or something like that. It's phishing resistant by tying the key to the particular service or server that you're authenticating against, like I mentioned earlier there. The flow of this is something like this. It's got a request for authentication. You get a challenge back. The challenge is signed with the private key. That signature is then sent back to the authentication service that verifies it with the public key, and then authentication is successful. So this is the flow of authentication. It's not the flow of registration. Registration, it's somewhat similar, but it's obviously not exactly the same. You can go to, I think it's WebAuthn.io. They have really good videos, short little videos that explains registration and all these things. So Passkeys is built on top of WebAuthn. You've probably heard of Passkeys because Apple, Google, and Microsoft all got together and supported this in various points of times, but they are supported by services that these companies provide and also by their browsers, right? I'd say the one kind of big thing with Passkeys is essentially that you can, it's almost like it's synchronized WebAuthn. You don't have to synchronize Passkeys either, but I can register a passkey on my laptop and it can essentially synchronize to my phone. Apple do that, I believe, using the, whatever they call the iCloud keychain. So that removes sort of this, like I have to register this on each and every device that I have. So passkeys can be synchronized from that perspective. I don't remember how Google does it, but I think they can do it too. All right. That was the setup. Now, hopefully this works. It does, so far. So I have a Curity server running on this laptop. It's exposed to the internet using a reverse proxy. That's the part that broke an hour and a half ago. It works now. This is a simple demo application that we've developed. It's an iOS application. If I hit start authentication here, it's somewhat slow because of the Wi-Fi here, I think. Here I could get any number of things happening, but I have a passkey authenticator. It's only asking me for my username. How this is rendered is in control of the app developer. What actually happened was underneath the hood, this mobile application got sort of like, it started talking to the Curity server. You got a JSON payload back essentially that tells me, or tells the application, oh, I have a passkey authenticator for you. We could change it server side so that it's username and password authenticator, and then this rendering will look different, right? But all I have to do here, I type in my username. This is the passkey that I have it registered popping up. I click continue, and it does Face ID authentication to unlock the passkey, and now I'm authenticated. You can see how I kind of wanted to build up this with some information before just showing the demo, because it is dirt simple, right? But that's also the point I want to make. You can make authentication on a mobile device super slick with no sort of context switching into a browser, no password. This is it. Like, this app now has access to an access token here that was issued to the application, running an OAuth code flow underneath the hood. That was it.